Okay, so we were discussing with the decision tree. Okay, so what happened with respect to that of a decision tree? Can you see this? Just I have worked out. Okay, so what happens whenever I want a decision tree? So I'm going to give the input. Obviously, the input will be a data set. Okay, so when I give a data set and apply some algorithm, as a result, I will get two things from a decision tree. Either I can get a classification or I may get a regression. Okay, so you know what is the meaning of a classification? It is going to classify the things. Okay, and regression, Sunita is going to handle the regression today. Okay, so even if you guys are interested in doing association rule, cluster analysis, and even ANN, okay, artificial neural network, these are the three concepts to be covered in the upcoming classes. Is anybody really interested and want to give the demo to your friends? You can come up with me and you can join with me and you can give. Okay, so that's what it's a part of teaching and learning process. I'm teaching and learning also. You people also teach and learn. Okay, nothing more. So that you cannot say that sir is get bored and he is giving the assignment. No. Okay, so if you do, it's good for all of us. If he doesn't do also, I'm going to do it. Okay, so what happens, if people can see, it's a process, it's a decision tree where some guy is applying for the loan, and he wants to know whether he may get the loan or not. Okay, so he has taken two things. One is a credit score and one more is income. Okay, based on these two variables we can say. Okay, so before going to that, always the top of the node will be the root node. Okay, so and this is one called as decision nodes and this is called as leaf nodes. Okay, so what happens now, so whenever I'm going to apply a data set, I'm going to apply to the root node. Okay, from the root node there will be two decision nodes, and when I'm going to call the leaf node, okay, the leaf node is the one which doesn't have a branch. Means further I don't have any classification, we are going to call it as a branch, and such a node is nothing but called as a leaf node. Okay, so now what happens when I'm employed? Okay, I'm an employed guy. Employed means what? Whether it may be a private sector, government sector, or even a business. Business is also a type of employment. Okay, so what I'm going to say, if I'm employed, yes, my income is high, then is loan approved. Okay, if I'm employed, my income is low, then loan is rejected. If I'm employed, I'm having credit score. Okay, if I'm not employed also, but I am having a credit score which is very very high, then my loan is approved. A stands for approved. If it is low, then I'm say rejected. Okay, so based on this, I'm having 3 S and 2 N's. This is how I'm going to find out the error rate. Okay, so out of 3, I'm going to make all this data set as G1 and all this data set as G2. Okay, so this is a decision nodes, the nodes with a branch followed by a root node. They are going to call it as a decision nodes, and the nodes which don't have a branch, they are going to call it as a leaf node. Keep it in your mind. And this is a root node. Okay, so only the thing, this is how the decision tree is going to be helpful. Okay, so coming back, this is what I told you. Decision tree is a simple way. That's a very big, very simple example which I have given to whether to approve a loan or not. Okay, so very very simple example where I can show that whether a loan can be applied or not. So this is how the decision tree works. Okay, so now what happens, decision tree is a simple way to guide one's past decision. We are going to consider the variables. We are going to consider the variables which is going to give the answers for our question, and keeping these variables, we are going to try to find out the decision trees. Okay, so yeah. Okay, yeah, so that is how the decision tree works. And if people have seen the example of last class where we are predicting the heart attack disease, so there is some problem with the decision tree also. Means imagine a conversation between a doctor and a patient. Again, there is a decision tree plays a very very important role. If I'm a patient, I'm going to meet to the doctor, and doctor, what the doctor will do, doctor will ask a series of questions. Okay, what is the reason for your sickness? Okay, if I couldn't able to answer him in a proper manner with a reasonable answering, if he doesn't put a reasonable question, or if I doesn't answer in a reasonable manner, then what happens, then I may not settle in a proper conclusion. Proper decision tree doesn't may frame. Okay, so this is how experts, what they are going to do in order to solve this kinds of the problem. They use decision trees with some rules. Okay, So you know what is the rules. The rules is very clear. Your question should be very clear, means that is going to consider as a variable. Okay, for every question they ask and creates a potential answers, that is in terms of a branches. Okay, for each branch the experts should know how to proceed. Okay, this is how the things continues, and the end of the tree is reached, that is nothing but called as a leaf node. Okay, human experts always learns from the past experience, that is where the supervised learning comes. Okay, so decision tree is purely a supervised learning, but whenever I go for a cluster analysis, I can say cluster analysis is unsupervised learning, because you are going to group a set of data which are very near or far, not based on the experience, just you're based on the present situation. So that is where the things comes. Decision tree problem is a purely a supervised learning. Okay, uh, supervised learning. Okay, so then comes the decision tree problem. Okay, the decision tree problem. Uh, yeah, so when I say the decision tree problem, it's based on how often the which makes the correct decisions. Okay, yeah, just a minute. The more okay, the more training data is provided, the more accurate its knowledge extraction will be. Okay, means that is what I told you. If it is a supervised learning, what happens in case of a supervised learning? You are going to give the past data. Okay, so when you are going to give the past data, obviously it is more accurate knowledge and will be, and thus it makes more accurate decisions. When you are giving an accurate, yeah, network problem, can't do anything. Okay, so that's what I was discussing. The more training data is provided, okay, the more accurate its knowledge will be. Okay, so you should decide on the variables. That is a very very important question. Now we have decided in the previous example on two variables. One is whether he is having a good credit score or he is salaried, he is having a good income. Okay, if he's having a good credit score, even though he is not employed, the company will provide him the loan. And in the same fashion, if he, okay, yeah, fine. Okay, so the more variables the tree can choose from the tree will come out with a better higher accuracy, but the variable should be in such a manner that it should give the answer to the question. Okay, so I have chosen while taking the loan only two variables. One is nothing but credit score and income. If I'm having a good credit score, even though I'm not an employee, my loan is approved. If I'm having low credit score, even though I'm not employed, the loan is rejected. If I'm having a high income, okay, then obviously my loan is accepted. If I'm having low income, my loan is rejected. So this diagram is a very simple example of a decision tree, where we need to decide on the decision node variables, and here we need to decide on the leaf nodes. Okay, so this is a very simple example which will help you to understand about the decision trees. And in addition, decision trees should also have an economy. Okay, it should be economical one. It should not be more high cost. Okay, so again, if you remember the example of this, okay, where we are having an outlook, where we are having variables like sunny, overcast, and rainy, and even we are having windy and humidity. Now, if I want to take the same example, okay, I need to decide on a game. Suppose think I need to play a cricket in India. Okay, so I need to decide based on the decision tree, that whether the game can takes place or not based on these variables. Okay, these are the different kinds of the variables, and based on these variables I need to decide that whether I can able to play the game or not. This is how the things decide, because if there will be some rules that is being implemented by ICICI. Okay, so that's what cricket board, ICB, what I can say. Okay, Indian Cricket Board or International Cricket Board, whatever it is. So what they are going to do, they need to book the tickets. Before booking the tickets, they need to confirm with the weather people, because if they book the tickets and then some due to weather problem, if they cancel it, then again they are going to go in huge loss. There where again the decision tree comes into picture. Okay, now we need to make a decision based on the past data results. Okay, that is the results of the weather station which has already given that whether we need to play or not. Okay, so this is how the outlook is. Okay, if there is a sunny, temperature is hot, humidity is high, and wind is falsy, you cannot play. And if the outlook is overcast, temperature is hot, humidity is high, and even the windy is false, yes, you can play. This is what the predictions are. Now what they are going to do, there are some exercise they are going to apply. Okay, even though you are going to have a good number of past data, okay, as mentioned earlier, it is difficult to decide on one particular row. Means in certain situation you don't have your data set, then how you are going to decide? That's a very big problem. Okay, so you cannot just depend on the past experience. This is one problem. And second thing is nothing but second more problem is nothing but searching to the entire past database. It is a time consuming process. Okay, it's a very big time consuming process. And then comes, what if data values are not available for all the variables? Okay, yeah, you cannot you cannot bid on only 2 to 3 variables. Okay, if not all the variables, again there is a problem with the decision tree. Okay, so how we need to construct a decision tree? As you know, there will be a root node. In between nodes are nothing but the nodes with the branches, they are going to call it as a decision nodes, and the nodes without the branches, they are going to call it as a leaf nodes. So now you people can take the example of the same example. Okay, the same example of final decision tree, where I can have a questions like what is the outlook, what is the temperature, what is the humidity, and what is the wind speed. Okay, a creation should be used by one of these questions, and even it should not be expensive. And another way is nothing but is that if one is allowed to ask only one question, then which one he will ask? And the most important question is nothing but it helps to make the correct decision and with fewest error. Now, how to find out the error? People can see here in Outlook. Okay, if the sunny is no, okay, in the Outlook, if I take the example of the Outlook, okay, so Outlook, if I say sunny, sunny is going to appear in 1, 2, 1, 2, 3, 4, and 5 times. Okay, out of which it appears no for 2 times and yes for 3 times. Then what is an error rate? Error rate is 2 out of 5, because it is going to give the correct results for 3 times and not correct no for 2 times. So this is how we are going to keep on constructing a decision tree. Okay, so in the same fashion, out of sunny, if we are going to take overcast, overcast is going to give s, overcast is going to give s1, 2, 3, 4, 4. All the 4 times the overcast say yes, you can play the game. So you see the variables: overcast, hot, high, but windy is false. Where is overcast? Okay, so people can see overcast, yes, yes for all. So 0 out of 4, it is yes, you can play any situation, you can play. But you need to see for the situation where there is humidity and wind with respect to sunny and rainy. Okay, we already see the outlook, we already see the outlook with respect to sunny. Okay, when we see the outlook with respect to sunny, people can see, yeah, yeah, what we can do when we see with respect to sunny. Okay, the humidity is high, we cannot play. With respect to sunny, if the humidity is normal, yes, we can play. This is how the things goes. Okay, this is how the things goes. Okay, so this is how the things goes, and this is how we are going to make the decisions. So now if people can see, even overcast I can play all the time. If there is a rainy, now if people can see, if there is a rainy, if there is a rainy, outlook is rainy, and even though windy is false, you can play. If there is a rainy and in the windy is true, you cannot play. So how you people are going to decide for the error factor? Okay, so you people can see here again, if there is sunny, no, 2 out of 5. Overcast, every time you can play if the variable is overcast and yes, and if the variable is rainy and yes, you can play 3 times out of 5, and two times it say you cannot play. So the total overall rate is nothing but overall error rate is 4 divided by 14. Okay, 4 times you cannot play. That's 12 times. Just 10 times you can play. This is how the things goes, and this is how the decision tree construction is. Okay, a similar analysis can be done for the other 3 variables. At the end of all this analytical exercise, the following error table will be constructed. Okay, for outlook, this is a variable. For temp, this is a variable. For humidity, this is a variable, and for windy, this is a variable. Okay, so this is how the total error rate is going to be calculated based on the decision tree. And if people can see same here. Okay, they have made yes whether to play or not, and whether to play or not.
In the same fashion, they have constructed the error rate, total error rate, and yeah, the total error rate for all the constraints. And when you apply this in a software, this is how your program is going to give the output, a decision tree. Outlook, which is equal to sunny, and equal and which is having a humidity is high, then you cannot play. Okay. Outlook, which is very sunny, even if humidity is normal, yes, you can play. 2 out of 0 chances are there. 4 out of 0. These are the things. And the same fashion, they have taken one more example with respect to that of a loan approval, okay, which we have done already, where we have taken only credit and income. But even there will be many constraints like age. Age is going to play a very important factor with respect to that of applying a loan. Okay. Job, yes, he is jobbed or he don't have any job. Whether it's a house loan, yes, he's having a house or not, or whether it's a credit score, I can say credit. So this is how again we can you people can try to implement your own decision tree. If you ask me, take the assignment like this for loan approval based on this terms and conditions, and try to draw your own decision tree based on this condition, and display whether how many number of times he can approve with a loan, or how many number of times he cannot able to approve with a loan, and kindly try to find out the error rate. This is the best way of learning the decision trees. Okay. And even some investments people can do based on the city size, average income, local investors, and awarenesses, and again you can take a decision. Okay. Somebody has unmuted, guys. Padmashree. Okay, fine. Okay, this is how the things goes with respect to that of city, even with respect to city sizes. Okay. If it is a very multi, getting a credit card in a Bangalore is very big, easiest task when you compare to that of getting a credit card in case of Tumkur or Dubai. Okay, there will be a number of options more opened when you are going to go for a big city. Again, you people can apply the decision tree for getting the credit card or not based on some variables. And who is going to decide the variables? You and the person who is developing the decision tree, they together, both together are going to decide the decision variables. Okay, so this is how the things goes. Okay. This is all about the decision tree. Now I request Sunita to take over and let her explain about the regression. Okay, please guys, WhatsApp me if anybody is interested to do any of the concepts. Really, people will learn. Okay, doing classes, making a process of learning. Okay, Sunita, are you there?
Yes, sir.
Okay, you start sharing your screen.
Okay. Good afternoon, everyone. Am I audible to every? Hello.
Yeah, you speak little louder. You are audible, but you speak little louder.
Okay. Good afternoon. So now I'm audible.
Yeah, yeah, you are audible.
Good afternoon. I'm Sunita, and today I'm gonna talk about a topic called regression. And in this session, we'll get to know what is regression and what is correlation, and we'll look at few visuals of relationships, and we'll take an example of regression and classification, how the regression classifies based on the number of independent values and dependent values, and the type of curve and type of output we get. And we'll look at the non-linear and linear regression and logistic regression, and at last we'll look at the advantages and disadvantages of regression models, and finally we'll conclude this. And coming to the introduction of regression, regression is nothing but a technique, statistical model where we get to know the relationship between the two variables. In simple terms, that regression is that we'll get to know the relationship between a independent variables and a dependent variable. Whereas dependent variable, we can also call it as a target, and independent variable is like features which we normally take in our data set. this models, in this data set there can be number of independent variables, but there should only be one dependent variable. So the main agenda behind this is to get a best fit curve. That is, when we get a best fit curve, we'll get, how can we get that is based on the correlation coefficient value. And this, to get this best fit curve, we go through these regression values and will which are best fitted models for this. And the main key steps is, first we'll take the data set, then we'll establish which are interested dependent variable, then we'll visualize the dependent variable to the rest of the independent variable, and last we'll get to know the which is the most predicted value, or which is the value which we need to predict. And the regression comes under supervised machine learning model, where the output is already known based on the previous data sets, and we'll predict the upcoming or the forecasting the next further outputs. And what is the main thing while we do regression is to know the best fit line, as we have dealt before, and it indicates the relationship between the dependent and independent variables. How is the relation exist? If it is if it is related perfectly, then we'll get a best outfit model. And we'll also deal with the strength of impact, how the independent variable impact on a dependent variable. If there how What if there are many independent variables, and what if there is only one independent variable? And the there are how can we differentiate, how can we classify these regression models is based on, we can see here number of independent variables and the shape of regression line. Based on the number of independent variables, we can have these types, like simple linear regression and multiple linear regression. Simple linear regression is where we have only one independent variable and one dependent variable. And whereas coming to multiple linear regression, where we have multiple independent variables and one dependent variable. Like many independent variables will be there. And the main thing is we need to get a best curve, so that we'll deal with this further, and we'll come to this after the regression. And how can we get this to apply the regression models, we need to have a perfectly correlated variables to enter. That is, which are the variables which can give good output or good result or accurate result. Based on the correlation factor or the R value, we can determine that. That is, R value can be determined by the correlation is nothing but a relationship between two variables. So this correlation value can vary from 0 to 1. If it's a 0, there is no relationship between that two particular values or the variables. If it is a 1, if the value is 1, there is they're perfectly correlated. There is exactly, this is the best we can get a perfect output based on based on these two variables. So how can we get this R value is using this formula. Using this sorry Using this formula, we can get the coefficient of correlation value, that is x minus x bar into y minus y bar divided by this x minus x bar square into y minus y bar. This is x bar is nothing but mean values of all independent variables, and y bar is mean of all dependent variables. And if we can take an example that for there are many correlation depends on three. Like we can see in this figure, there are three types of correlations, like positive, negative, and there is no correlation. As we have seen that no correlation is where the value is zero, the two variables don't exist, so we will not consider them at all in our data set. If it is positive correlation, is nothing but where if the one variable, if the dependent variable vary according to the independent variable linearly. Like if we want to take an example, we can take a industry company where a company invests much more amount of much amount in advertising. Hence their sales will also increase, as people will get to know about their product more, and thereby sales will increase, which results to positive correlation. That is, the amount spent on advertisements is directly proportional to the sales. Whereas negative correlation is the price. If the company gets to know that the people are taking a much, the product is on demand in the market, if companies tries to increase the price of that particular commodity, then gradually the sales will decrease. People will not show much interest in taking that. But even that depends on the quality of the product. But generally, if price increases, the people don't find much interest in taking that particular commodity. So we can see the three diagrams here, that is positive correlation, negative correlation, and no correlation. Whereas in positive, that is, we have taken an example that the amount spent on advertisements is directly proportional to the sales increment in the company. So whereas negative correlation is the where price increases and the sales decrease. No correlation is, we can take example of anything like where the two variables are not at all related to one another. And so we'll get to know that these two variables are directly proportional to each other. So data sets.